Hi everyone. In this video, we'll go through problems on finding intervals for which the functions are either increasing or decreasing. Let's take this example in which this particular function is increasing and decreasing. So there is a function, it will increase, it will decrease. You need to find the values of those x, right? You need to find the range, the values of x or the interval in which this function is increasing and decreasing. So what you'll do, you'll first step one, first find the derivative of this function, right? Now, when you get the derivative of this function, you have a polynomial function here, right? You have to find the values of x because they've not given any value of x here, right? They have not given any value of x. We need to figure out the value of x. That is what is called as interval. We need to figure out the values of x in which the function is increasing and decreasing. So now we need to find this value of x here, right? So using any method, right, you can find the value of x using factorization method or sum product method or using the formula. Any method you can use and find the values of x here. Once you find the values of x, right, say you get these values of x, you will have to use one of the techniques is use wavy curve method. Wavy curve method to figure out at what interval it is decreasing and at what interval it is increasing, right? Just to find the increasing interval or the increasing range of values or decreasing range of values, you need to use this wavy curve method. How do you use this method is, you get the values of x, right? In the ascending order, plot the points. You start with minus infinity, end with plus infinity, right? And then you take the points. You take it in increasing order. So first point is minus 2. Take the smallest number first and then take the bigger number. So first is minus 2. The second number is 3, right? Now you need to figure out the signs. So you take the rightmost part, the rightmost interval. You need to find out what sign it will be. Will it be plus sign or minus sign? For that, you will have to use the function which gave this value 3. Which gave this value 3? This one. X minus 3. When I make x minus 3 as 0, I'll get x is equal to 3, right? So now you take the coefficient of this x. Coefficient is number next to x. Now there is minus 6 here. If I multiply this minus 6 into x, it's going to become minus 6x. So it's a negative coefficient. Minus, negative. So you put negative sign here. Then you alternate. Minus plus minus. That's all. Now, wherever there is minus, that becomes decreasing. Wherever there is plus, it becomes increasing. So, minus, that is minus infinity to minus 2, it is decreasing. Then 3 to plus infinity, it is decreasing. It is increasing only here. Between minus 2 and 3, it is increasing. Now that's how we find intervals for increasing and decreasing. Now let's try this step by step, right? So that it becomes more clear. First step is derivative. So it will be 0 plus 36 plus 3 2s are 6 into x minus 2 3s are 6 into x square. So this is a derivative. Let's try to take common. 6 is common. Put it in the ascending order. Let's put x square first. 6 is common factor. So you'll be left with minus 1 x square. Then you'll have plus x. Then you'll have plus 6. Correct? Now I can remove this 1. Right? I can put as minus x square. Right? So now I'll take this minus out. So it will become minus 6 x square. So signs will get reversed. The moment I put minus outside, signs will get reversed. So minus x square will become plus x square. Plus 6 will become minus x. Plus 6 will become minus 6. Now I need to find the values of x. I removed the minus sign, so it becomes easier to simplify, right? Now let me find the values of x. So x square minus x minus 6. What are the factors? So what should be the numbers? You have to get, when you multiply, you should get minus 6. And when you add, you should get minus 1. Coefficient of this, minus 1. That is, product should be minus 6. Sum should be minus 1. This is sum. This is product. What are the numbers? Product should be minus 6. That is 2 and 3. I can take 2 and 3. It should be minus. So I'll put minus 3. It'll be minus 6. And sum, when I add these two numbers, I should get minus 1. So 2 minus 3 is minus 1. That is nothing but here, coefficient of x. So the numbers are 2 and minus 3. Basically, it's nothing but x plus 2 and x minus 3. Right? X plus 2 and x minus 3. So I'll put minus 6 into x plus 2 into x minus 3. We'll have to always equate x plus 2 is equal to 0 and x minus 3 is equal to 0, which is nothing but x is equal to minus 2 and x is equal to 3. Now we'll have to plot these values and use wavy curve method. First I'll write minus infinity and plus infinity. What are the points? Minus 2. What is the second point? 3. Now what should be the sign? From which function I've got 3? I've got it from x minus 3, right? Because of the number here is 3. And I've got 3 from this particular function. What is the coefficient of x? Here it is 1. But let's not forget this minus 6, right? We should not forget this minus 6. If I multiply minus 6 with x, it will be minus 6x, right? So that means coefficient is negative. So I have to start with negative. Then alternate. Minus plus minus. Now, wherever there is minus, it becomes decreasing. So let's write it. Decreasing at, let's put the interval. Minus infinity to minus 2. This is how we put the interval. Minus infinity to minus 2. Union here. 3 to infinity. This is where it's decreasing. And increasing at, this is where it's increasing. At minus 2 to 3. We can also say this as at x less than minus 2, right? That is, anything when values are less than minus 2, that is this side, it's decreasing. And when x is greater than 3. And here in between these two, you have increasing function. Let's take another problem. Find the interval in which the function is increasing or decreasing. So you have this function. You have to say at what intervals it's increasing and decreasing. Let's solve this step by step. So first let's find derivative. So 3 2s are 6 x square, 15 2s are 30x minus 84. Right? This is the derivative. Now I have to find the interval. Right? I have to find interval when it is increasing and interval when it is decreasing. So if I have to find the interval, I have to find the values of x. I need to find values of x. Let me take 6 common here. X square minus 5x minus 14. Now I have to find the roots, or I have to find the values of x. So it would be 7 2s are 14, right? Let me solve this. 7 2s are 14. I can take two numbers. 7 2s are 14. I need minus 14. So let me put minus 7. And when I add these numbers, I should get minus 5. When I add, I should get 7 minus 5. Minus 7 plus 2 is minus 5. So the roots are x minus 7 and x plus 2. Right? So it is 6 into x minus 7 into x plus 2. Basically, x is equal to 7. X is equal to minus 2. See, you can write it like this also. For increasing function, derivative of the function should be greater than 0, right? Which means 6 into x minus 7 into x plus 2 should be greater than 0. Now I'll use a wavy curve method. I use wavy curve method to find the interval, right? So we'll start with minus infinity plus infinity. The points are 7 and minus 2. This is the smallest one, so I'll put minus 2 here. After that, it is 7. Now, what should the sign be of the rightmost interval? Let's look at the function which is giving 7. Function that is giving 7 is x minus 7. Let's not forget this 6 here, right? You have 6 here. What is the coefficient of x? It is positive. When you multiply 6 with x, it's going to be positive only. So we'll start with plus sign here. Then alternate. So wherever there is plus, this is increasing. This is increasing. So what is the increasing interval? Nothing but we'll write it as minus infinity to minus 2 union 7 to infinity. This is increasing function. Now similarly we'll have to do decreasing function. What is decreasing function? Derivative would be less than 0. This step is important. 6 into x minus 7 into x plus 2 less than 0. Just write down this step, then come to the wavy curve method. This is where it is decreasing. Wherever there is minus, that's where it's decreasing. Decreasing between minus 2 and 7. So decreasing function at minus 2 to 7. Minus 2 to 7, it is decreasing. So let's take this another problem. You have a function, find the derivative. When you find the derivative, you get 2x square into 2x minus 3. So here, if you simplify this, when this 2x square comes this side, it becomes 0. You are left with 2x minus 3 is equal to 0. Now, for increasing function, derivative should be greater than 0. So, 2x minus 3 greater than 0, which means x is greater than 3 by 2. If I shift all the values on the right hand side, I'll get x greater than 3 by 2, right? So, the function is increasing when x is greater than 3 by 2. Greater than 3 by 2 means it can go till infinity. 3 by 2 till infinity. Similarly, for decreasing, derivative function is less than 0. So, 2x minus 3 is less than 0, which means x is less than 3 by 2. So, the interval would be less than 3 by 2 means anything less than 3 by 2 is infinity, right? Till infinity, minus infinity to 3 by 2. So, decreasing at minus infinity to 3 by 2. So, basically you can imagine like this, 3 by 2, this is minus infinity, this is plus infinity. Anything greater than 3 by 2, that is this side, it's increasing. Anything less than 3 by 2, that is this side, it is decreasing. This is decreasing, this is increasing. Since there is only one term here and there is only one value of x, you don't have to use any wavy curve method, it is simple here. So this is another function. Everything is similar, but here at the end you get square function. X minus 1 the whole square you get. The moment you get a square function, you can simply write it as increasing for all values of x. Because it's a square function, square function always gives positive value. So it's increasing for all x. This is another example, right? Again find the derivative. Increasing function, derivative should be greater than 0. So you equate this values to greater than 0. X plus 2 and x plus 1 should be greater than 0. So now first get the values of x. When you say x plus 2 is 0, the value of x is minus 2. When you say x plus 1 is equal to 0, value of x is minus 1. Right? I can even put greater than here. Right? I can even put greater than here. So the points are minus 2 and minus 1. Now plot them. Minus 2 comes first. Remember, negative value, right? Minus 2 comes first and then minus 1. Now you need to find what is the sign. So find the coefficient. From where are we getting minus 1? We are getting minus 1 from this function, right? Minus 1 from this function. Let's not forget 6 here, right? When I find the coefficient of x, when I multiply with 6, it's going to become positive only. So we'll start with plus sign. Plus, minus, plus. It's increasing here and here. Here it is increasing and decreasing between minus 2 and minus 1. So increasing function interval is minus infinity to minus 2, union minus 1 to infinity. Any value less than minus 2 will be increasing. Any value greater than minus 1 will be increasing. So x less than minus 2 and x greater than minus 1. This is the interval. And for decreasing function, the interval is between minus 2 and minus 1. So with this, we've come to the end of this particular topic. If you've liked this video, do press a like and share it. Thank you.